Now I need to add another column in there, second. And while we are at it, why not add the nano as well? And this becomes my primary key. Is it easy to modify a primary key in Cassandra? No, for the right reasons. Because Cassandra organizes the data based on the primary key. We cannot arbitrarily go out there and change the primary key. If you change the primary key, the data organization on the disk breaks. For example, if I did allow you to modify the primary key and add the seconds and nano after Cassandra has accepted data, then what happens to the existing data? Where are you going to get the seconds and nano from? It's not going to go back and relook at and reorganize and modify all the existing set of data, because there can be huge volumes of data across thousands of nodes. So a simple alter table would mean a huge impact to the existing Cassandra cluster. So how do we solve this? We create a new table and we do a data migration. We read the data from the existing table and we reinsert that into the new quote unquote model. In addition to that, why don't we take a look at, okay, right, once every second. So obviously this is not 1440, right? I think it's going to be some 86K. That will be the size of my partition. I want to increase the velocity even more. Let us say I do twice every second. So this is going to be 86K times 2. That's about 175K. That's a lot of records for a given partition. So my partition size has become close to 175,000 records. Needless to say, if this size continues to increase, Cassandra will begin to struggle. So here are two numbers in terms of best practices that you must keep in mind when you model with Cassandra. First best practice: the sum total, the size of the entire partition should be less than 100 megabytes. The number of records in the partition key should be less than 100K. There are two hundreds that you need to remember. Now, if you work backward from these best practices, you can clearly see, although my partition key is able to handle, with the nano in there, will be able to handle the storage of all the records so that it does not suffer from upserts. Clearly, this number is breaching the best practice. So how do we address that? That is exactly where you may want to get in either a surrogate key. A surrogate key is something that does not exist naturally in the world. For example, bucket or first half, second half. Well, first half, second half does exist naturally in the world in terms of time. But how about a bucket? Suppose I introduce a new column in the partition key called bucket 1 and bucket 2. Bucket 1 is the first 12 hours worth of data and bucket 2 is the next 12 hours worth of data. Alternatively, I could also say, hey, you know what? I'm going to remove this parentheses and I'm going to shift it here. I just brought the hours in the partition key. With this simple change, what will now happen? Every 60 minutes, my partition key will change. So with this modification, what's going to happen? If I use this particular partition key, and if I have twice a second, my velocity is twice a second, and because of this partition change, right, I'm going to store 60 minutes worth of data times 2. Well, twice a second, right? Yeah, that will be what is going to be 60 minutes? That's 60 minutes, and 60 times data times 2, right? Yeah, that's going to be what it is. I'm going to call it new partition key. That's the size of my partition. Make sense? So what you'll have to basically look at is how you need to manage your partition key, how you intend to do that. And you can clearly see your velocity has a significant bearing on the way you create your partition key. And this is one of the modeling challenges that you have to keep in mind. And you also noticed that if this decision is not taken upfront, you're going to have problems in the long run. Now you might wonder, right, what happens if my business requirements change? If your business requirements change, you do have to modify the partition key. And the way to do that is create new tables and transfer the data. That's the only option that you have. You might wonder, isn't that an operational overhead? Yes, it is. But if you really look at the kind of problem that Cassandra is solving, which other data store system will be able to give you a microsecond latency with respect to data insert and get across trillions of records? Just to quote, Netflix does 1 trillion operations per day. So naturally, when you want to get something at that scale, you need to sacrifice something. So operational discomfort, if I can use that word, right, is unfortunately a reality. But I'll tell you what, the moment you start working with Cassandra over a period of time, right, you will begin to predict these kind of requirements. But can you eliminate, this all completely? No. I think there will be some sort of a remodeling at some point in time.